Number one gives us a system and it wants us to solve the system by graphing the equations. And you can either do this by hand or using technology. And then we're going to explain how we could tell without graphing that there is only one solution. So I am going to graph these ones using technology. So I'm going to show you how to use Desmos for this. And Desmos is an online platform. So if we go to desmos.com, so you can just type in desmos.com, then you can hit the graphing calculator button here. Then we're going to be able to type in these equations. And one of the nice things about Desmos is you can just type in the equation, how it looks. So you can just type in the 3x minus y equals 17 versus a graphing calculator. You have to have it solved for y. So we're going to graph the first one, and then we can type in the second one, x plus 4y equals 10. And then we can see the solution here. You can also grab the screen, just click down and move it if you would like. And then you can actually just click on the intersection point, which is the solution. So then we can see that the solution is the 0.61. So then you could write down, that solution in your workbook is the 0.61. And then we want to explain how could we tell without graphing that there's only one solution to this system. And so when we look at these equations, there's going to be one solution if we can't get these to be the same values at the same time. So like both of these aren't 3x's and 4y's. And that just means that their slopes are different. So the equations are, they're just very different equations. So when we're looking at this, we could say we know there will be one solution because the coefficients, the numbers in front of, so the coefficients of the variables are not the same. So one thing, and we'll see this as we keep going, but if it was 3x minus y equals 17 and it was 3x minus y equals 19, we would have no solution because these numbers are the same here in front of the variables, and then these two are different. And so that's what you're kind of looking for. If it's just very different equations, then there's going to be one solution. Number two, consider this system of equations without graphing. Determine how many solutions you would expect this system of equations to have. So now when we look at this, we see now these ones are in slope-intercept form, right? So they're solved for y, and then we have the mx plus b. So this is your slope, and the b is your y-intercept or your starting point, right? So these two have the same slope, and they start at different points, okay? Now I'm going to just put a graph here so you can kind of think about this. But this one is starting down here at -3 with a 4/5 slope. And then this one is starting at 1 with a 4/5 slope. So they're going in the same, they're rising and running at the same speed, but they start in different places. So they aren't going to have a solution. Okay, so these equations have the same slope. And start in different places. So they are going to be parallel lines. And parallel lines are never going to cross, right? So they have the same slope and different starting points. So they're going to be parallel lines. This means they'll never cross. Therefore, they won't have a solution. Since a solution is a point that they share. All right, then part B asks us to actually try solving the system algebraically. So again, not by graphing. and describe the result that we get. So these are both solved for y. So I'm just going to substitute in this for y in this equation. So we're going to put 4/5 x minus 3 equals 4/5 x plus 1. So now if I go and subtract 4/5 x from both sides, 4/5 minus 4/5 is 0. So this side is just going to be -3. 4/5 minus 4/5 is going to be 0. So we get 1. And so now all of our variables canceled out. And this statement says that -3 is equal to 1, which is false. Okay, so -3 does not equal 1. So then that means that there's no solution to this system. Number 3, how many solutions does this system have? Explain how you know. So you could go ahead and try and solve this. So if we take a look here, I'm going to divide this by 5. So this bottom equation, we're going to get down to y equals, 15 divided by 5 is 3. And then 10 divided by 5 is 2. So that's that equation solved for y. So then I'm going to take this top equation and solve it for y. So I'm going to subtract 9x from both sides. So we're going to be at -3y equals -9x with a -6. Then I'm going to divide by -3 to everything. And we'll get y equals -9 divided by -3 is positive 3x. And then -6 divided by -3 is positive 2. And then we can see that these two equations are the exact same line. So that means that the solution to this system is going to be infinite because these equations are the exact same. So there's infinite solutions because the two equations represent the same exact line. So whatever's a solution to this blue one is going to be a solution to the orange one as well. So if this was the line, okay, for the blue one, then this would be the line for the orange one, and all of these points would be solutions to both of them. So infinite solutions. Number 4, select all the systems of equations that have no solution. So if we take a look in A, these ones have the exact same slope. Okay, they both have a -3 slope and they start at different places. And let me just rewrite this one as -3x plus 5. And then that bottom one is -3x plus 4. So these ones have the same slope but different starting points. So these are going to be parallel lines, which means no solution. B, so let's just divide by 4 here to get this solved for y. So this bottom one is going to be y equals 4x minus 1. These are the exact same line. Okay, which means that there's going to be an infinite number of solutions, not no solution, because they're going to graph right on top of each other. So they're going to overlap for all of eternity. So these have infinite solutions. This next one, I'm just going to multiply the top equation by 2 to see if we can get it the same. So 5 to 10 is multiplying by 2. So I'm just going to multiply by 2. So 10x, -4y, and 6. And then if I look at that bottom equation, they're the exact same. So again, they're the exact same line. So this is going to be infinite solutions. So we're looking for all the ones that have no solution. D, so if we look at 3x to get to 6x, okay, so we could multiply again by 2, this top equation. So then we'd have 6x, we'd have 14y, and we would have 84. Where the bottom one is 6x, 14y, and 50. So these ones are going to end up with the same slope because these are the same, but they have different starting points. Okay, so different starts. So these ones are going to be parallel lines if we were to solve them for y. And so this is going to give us no solution. You can also think of it as if you subtracted these, you'd get 0 over here because 6 minus 6 is 0, 14 minus 14 is 0. And then when you subtract here, you get 34, which is a false statement. So that's going to mean no solution. And then E, these ones have different slopes and different starting points. So these ones are going to cross. So this one has one solution, and we're looking for no solution. Number 5, solve each system of equations without graphing. And so you can kind of choose how you want to do this. I see that I can take this bottom equation and multiply by -3, which will get me opposites in the W. So I'll rewrite down 2v plus 6w equals -36. Then I'm going to multiply the bottom equation by -3. So that's going to give me -15v minus 6w equals -3. And this allows me to add these equations together. So then we end up with -13v, -6w plus 6w plus -6w is 0. -36 plus -3 is -39. So then we'll divide by -13, and we get that v equals 3. So then we'll take that and we'll plug it into one of these other equations. So I'll just do the 2 times v plus 6w equation equals -36. We are plugging 3 in for v. So then we get 6 plus 6w equals -36. We'll subtract 6 from both sides. So this will be 0. And then we'll get 6w. -36 minus 6 is -42. Then we'll divide by 6 so that we get -7 for w. So then that would be our solution for part A. Part B asks us to do the same thing. So just solve this solution or solve this system. So again, I see this bottom equation. So I look for opposites because I like to add. So I'm going to multiply by 3 here. So we get the top equation stays the same. And then this bottom equation becomes 6t plus 9u equals 12. So I just multiplied the bottom by 3. So you can either add these equations or subtract them because the t's are the exact same, the u's are opposites. I like to add, so I'm going to add the equations together. So 6t plus 6t is 12t, -9u plus 9u is 0, and then 10 plus 12 is 22. So then we'll divide by 12, and we get that t equals 22 over 12. But that simplifies because both of these divide by 2. So we simplify to 11/6. And you can do the decimal to this, but it's really long. And so I would just leave it as a fraction, which is actually going to be nice when you plug it back in here. So let's plug it back in to solve for u. So we get 6 times t minus 9u equals 10. And when we plug the 11/6 in here, that's where it becomes nice because you're multiplying by 6 and dividing by 6. So those are just going to cancel. So you get 11 minus 9u equals 10. So we'll subtract 11 from both sides. And we get -9u equals -1. So then we can divide by -9. And we get u equals positive 1 over 9 because those negatives will cancel. Number 6 asks us to select all dot plots that appear to contain outliers. So remember, outliers are data that are way away from the rest of the data. So A appears to have an outlier. B doesn't, because we don't have all the data centralized anywhere. C, all of the data is over here between like 40 and 60, except for these two. So those are considered outliers. D, all the data is between 0 and 6. And then we have this one way up here at 26. So that's an outlier. And then E, most of our data is between 2 and 16. We do have this number 20 out here, but it needs to be 1.5 times away from the third half of the third quarter of the data, which it's not. So it's a little bit away, but not enough to be considered an outlier. So just A, C, and D there. Number 7 gives us a system, and it just asks us, would you rather use subtraction or addition here? And this is completely a personal preference because you can use either. So either are fine. Subtraction because we have the 6 y's are the same. Addition because the x's are opposites of each other. So this is totally up to you. If you've been watching my videos, you know I prefer addition. So I prefer to use addition since the x's are opposites of each other. So negative 1x plus 1x will eliminate the x's. And I just prefer that because I think addition is easier than subtraction. That doesn't have to be your reality. So if you like subtraction better, you can certainly choose that one. Number 8, here's a system. Select all steps that would help us eliminate a variable and enable us to solve. So part A says that we would first multiply the first equation by 2. So the first equation multiplied by 2 would give us 12x minus 2y equals 18. And then it's telling us we would subtract the second equation. And the issue here is the subtraction, right? Because we have opposite numbers in front of our y, so we don't want to subtract. Okay, we would actually want to add. So part A is incorrect. B says multiply the first equation by 4. So 6 times 4 is 24. Then we have negative 4 when we multiply negative 1 by 4. And then 18 times 4 is 72. Then it wants us to multiply the second equation by 6. So we'd have 24x. 2y times 6 is positive 12y. And then 26 times 6 is 156. And then they ask us to subtract. And subtracting would be good because we have the same number in front of our x's. So this one would be good. Part C, multiply the first equation by 2, then add the result. So this is going to be this same thing we did right here, except for they changed subtract to add, which would be good because we have opposites in front of the y. So part C is good. D says to divide the second equation by 2. So our first equation stays the same. So I'll just write it up here. And our second equation, we're going to divide by 2. So 4x divided by 2 is 2x. 2y divided by 2y divided by 2 is y. And then 26 divided by 2 is 13. Then they tell us to add, which we have opposites, so that is good. And then E tells us to multiply the second equation by 6 and then subtract the result from the first. So our first equation is 6x minus y equals 18. Multiply the second equation by 6. So 24x plus 12y equals 156. And that's not going to be good because we don't have any opposites or anything the same. Number 9 asks us to consider the system of equations, and then it gives us some different steps here. So it says in part 1, what was done to the original system? So to go from here to here. And so we see that the second equation is the same, but the first one is different. Okay, so they went from 2x to 7x, 2y to 7y, and then 180 to 60. So if you don't know right away, take 7x divided by the original one. So the 7x divided by the 2x, and that gives you 3.5. So they actually multiplied the first equation by 3.5. And then explain why the system in step 1 is equivalent. So remember, this is the idea that if we do the same thing to both sides, okay, so we multiplied 3.5 to both sides of the equation, of the first equation. So the first equation is equivalent to the original, meaning they have the same solutions. So the system will also have the same solutions. So as long as you keep the equations equivalent, okay, by following legal math moves, then your answer will stay the same as well, or your solution will stay the same as well. Part B asks us, what did they do from step 1 to step 2? So now how did they go from step 1 over to step 2? So we can see they're still working with that top equation, or there's something changing there, right? So what they ended up doing here is subtracting the sides, right? So subtracting the 0.1x 7y and then 78. So they just subtracted these two equations because 7 minus 0.1 is 6.9. 7y minus 7y is 0. And then 630 minus 78 is 52. So they subtracted the two equations. And why is that going to be the same? So it's a very similar idea, right, to this one. So let's get this in here. All right, so they subtracted 0.1x and 7y from the left side. And they subtracted, was it 78? Yep, and 78 from the right side. And why can they do that is because we know that 0.1x plus 7y equals 78. So they subtracted the same value from both sides, which creates an equivalent equation and keeps the solutions the same. And then they want you to actually figure out what the solution is to the equation. So I'm just going to scroll back up here. So we know then that they divided by 6.9 to both sides and got that x equals 80. So then we just need to go ahead and plug this back into the other equation to figure out y. So we'll do 0.1 times 80 plus 7y should equal 78. So 0.1 times 80 would be 8. Plus 7y equals 78. So we'll subtract 8 from both sides. So 7y equals 70. Divide by 7, and we get y equals 10. So our solution would be 80, comma 10. So there would be our solution to that system.